Hey, it's Doust here. Our first lesson in our unit to get you ready for bio is an introduction to molecules and chemical formulas. There's so many cool molecules in our bodies, and knowing a little bit about chemistry can help us be successful in biology. And for example, we have adrenaline shown on the right-hand side of this slide. Adrenaline is the hormone you get when you're in a scary situation. It like amps you up so that you're ready to fight or you're ready to flee. And adrenaline's actually shown 4 different ways in this image. 3 of them are the drawings of the structure, sometimes with things labeled, sometimes with things color-coded, and we also have its chemical formula, the C9H13NO3. And which one you're going to choose to use really depends on the circumstance. If you're trying to do something quick, the chemical formula is great. If you're trying to explain how adrenaline interacts inside your nervous system, maybe you'll have a structure. And so it's really important that you'll be able to kind of go back and forth between what the structure is, like the drawing part, and the formula with just the symbols of the elements. And that's one of our main goals for today's lesson. So, first things first, atoms and molecules. These have specific definitions in chemistry, and at the start, students tend to kind of mix them up, but let's try to avoid that if at all possible. So our first row, those are all atoms. Oxygen, hydrogen, carbon, nitrogen, chlorine, fluorine. And then the next 2 rows, those are all molecules. So take a second. What is the difference between an atom and a molecule? Now, hopefully you notice that the atoms are all single things. Molecules are multiple atoms stuck together. And just pay attention that sometimes it's different elements. Sometimes it is the same element that is stuck together. But if it's multiple of them together, that's going to be a molecule. A more technical definition of what it means to be a molecule is when you have a group of atoms that are covalently bonded together. And we'll learn more about that in future lessons, but covalent bonding just means that they're sharing electrons. And so our example here is H2O, water. We have an oxygen atom in the middle and hydrogen atoms on either side, and between them they're sharing electrons. Now there's multiple ways we could show this sharing of electrons. If you look on the left, you can see oxygen is kind of color-coded red, and so it had 6 valence electrons at the beginning. Each hydrogen is color-coded white, and each one had 1 valence electron at the beginning. And now those electrons are kind of being shared. They're between the oxygen and the hydrogen. Most often, though, we're going to show it with a line representing shared electrons. So you have the element symbol, in this case H, and then a line representing shared electrons, and then the O for the oxygen. And then coming off that oxygen is another line, aka another bond, going to a separate H. All right, now let's talk about chemical formulas. Chemical formulas are used all the time in chemistry and biology, so we need to know what they mean. On the left, we have some molecules, a substance called ammonia, and on the right, we have a chemical formula. You need to know what all of these numbers and letters mean. So, coefficient, that's going to be the one out in front. Coefficients can change. So here we have 2 molecules of ammonia. Subscript. Subscripts show the number of that atom, and subscripts stay the same. So for ammonia, there's always going to be 3 hydrogens. And because there's only 1 N, there's not a number shown there, but ammonia is always 1 N and 3 H's. Always going to stay the same. And of course, the symbol, it's N or H. The first letter is always capitalized, If there's a second letter, it's not capitalized. All right, let's do a little practice here. We have 3 molecules, so it'll be kind of 3 separate formulas for each one: methane, carbon dioxide, and ethanol. Why don't you pause this right now and see if you can figure out what the formulas are. All right, methane had the 1 carbon in the middle, 4 hydrogens around the outside, so it's CH4. Notice I don't include 1 for the carbon, but I have to include the 4 for the hydrogen. Carbon dioxide, similar. There's only 1 carbon, that is 2 oxygen, so CO2. Ethanol, we have 3 different elements there. C2H5OH is one way to write it. You'll also see it written C2H6O. The order of the elements doesn't really matter. So for methane, if you had H4C, that's okay. For carbon dioxide, if you had O2C, that's fine. And ethanol, any order H, C, and O is okay. Now, you already know the formula for methane. We did that previously. But now we're going to have to use some coefficients. So how many methanes are there? There's 3. So you put that big 3 out front, indicating 3 methane molecules. How about carbon dioxide, right? We already know the formula of one of them, but how many molecules do we have? 6. So you put the big 6 out front, indicating you have 6 molecules. All right, now, what if I said you've got 4 CH4s? How many carbons would we have? How many hydrogens would we have in total? Now, that's what 4 CH4s looks like. Now we can clearly see that there are 4 carbon atoms in total, and 4 times 4 equals 16 hydrogen atoms in total.